Verification of Maxwell's reciprocal theorem for a cantilever beam. Last class, we have seen verification of Maxwell's reciprocal theorem for a simply supported beam. Today, we are going to see for a cantilever beam. So this cantilever beam made up of mild steel, having Young's modulus 200 gigapascal, and the cross-sectional dimensions width 16 millimeter and thickness or the depth is 6 millimeter. So let us choose any 2 points randomly on a given cantilever beam. So let us take this as 0.1 and 0.2. Okay. So in the same location here also, the bottom figure also 0.1 and 0.2. Okay. So now what the theorem says is, now for example, this is 0.1, 0.2. So at 0.2, we are placing the dial gauge. At 0.1, we are adding the weights. So at the point where the dial gauge is placed, it's nothing but we are trying to measure the deflection due to the applied load at 0.1. So this dial gauge gives you the deflection at 0.2 due to the load at 0.1. And here, this dial gauge gives you the deflection at 0.1 due to the load or weight added at 0.2. So we are trying to prove that deflection at 0.2 due to load at 0.1 is equal to the deflection at 0.1 due to the load at 0.2. Okay, so we are adding the weights. For example, beginning if you are adding a weight of 0.5 kg or 500 gram, so in that range, you will add a weight that is 0.5 kg first reading, the second reading plus 0.5 kg plus 0.5 kg. Like this, we are taking 5 readings. Okay, so in an order of incremental order of weight of 0.5 kg. Readings are noted down in the loading column. Then simultaneously, we are removing the weight 0.5 kg, 0.5 kg, 0.5 kg, and parallelly, we are noting down the dial gauge readings, and it is entered in the unloading column. Then we take the average of these two. Then that value will be multiplied by 0.01 so that you will get in millimeter. This is what we did in a simply supported beam also. The same procedure is being followed here also. Similarly, here also we will add a weight 0.5 kg, note down the reading here, the dial gauge. Again, add one more 0.5 kg, note down the reading from the dial gauge. Like this, we add the weights, okay, till we reach 2.5 kg, okay, till we reach 2.5 kg. So that means we are taking only 5 readings entered in the loading column. If you unload means for each 0.5 kg unloading, you have to enter in the unloaded column, then take the average. Okay. So after getting or after obtaining all these values, you plot a graph. Okay, you plot a graph with the help of Excel, or you can take a graph sheet manually also, you can plot a graph. You find the slope of that. That slope will be almost same for a straight line that you form with the help of a graph. Okay, that we'll see it. I will show you the short demonstration also for this experiment, how we are conducting this experiment, how we are adding the weights, how we take the readings from the dial gauge. It is very, very important that you must ensure that always your needle in a 0 position before loading. Before loading, very, very, very important. Okay, we are neglecting the weight of the beam and we are neglecting the weight of the anchor also. We are neglecting the weight of the anchor also during test. Okay, that's very, very important. So at the end of this, we will play the video also, demonstration video. I'm not following the same readings that I obtained in the video for our calculation. Okay, so for calculation, readings are different and the demonstration readings are different. Okay, don't confuse with that. Okay. So this is the aim and these are the apparatus required. Okay, so the length of the beam is 1000 millimeter. Okay, so width is 6 millimeter. Width is 16 millimeter and thickness is 6 millimeter. Okay. So this is what the theorem states: in any beam or a truss, the deflection at any point 1 due to the load W at any point 2 is same as the deflection at 2 due to the same load W at point 1. So this is the diagrammatic representation. We're applying a load here, measuring the deflection here. Okay, delta 2, 1. Then here we applied load at 0.2, measure the deflection at 0.1, delta 1, 2. So delta 1, 2 should be equal to delta 2, 1. So this is the procedure. So whatever I have explained in the beginning, the same thing is written here. So here for every 0.5 kg incremental, we record the values here loading. Then you remove 0.5 kg, you enter the unloading values, take the average of these two, multiply this by 0.01 to get the deflection value in millimeter. Okay, in millimeter. These are the direct dial gauge readings. Okay, these two columns, loading and unloading. So this is for delta 2, 1. Okay, you're just interchanging or shifting the points of the location of the anchor as well as the location of the dial gauge. So these are the plots, x-axis load in kg and average deflection millimeter. You can see two plots, okay. You could see the deflection almost 0.514 and 0.516 and 514, almost same. And this is Maxwell's method, the theoretical verification. I have just obtained this expression, deflection expression or deflection equation by Maxwell's method. We are just substituting the respective values. These dimensions are not same as the dimensions of our beam. Okay, this is for calculation purpose. I have taken the values. Okay, you could see here y1, the deflection at 0.1 minus 108.33 EI by divided by EI, and deflection at 2, y2 is equal to minus 108.33 by EI. You could see here theoretically also the values are, the deflection values are proved. We can see that the experimentally as well as the theoretically, this Maxwell's reciprocal theorem is proved for a given cantilever beam. Let us watch the video now. Okay, this is the setup. Okay, so 0.1 and 0.2. At 1, we are going to add a weight. At 2, we are going to measure the reading from the dial gauge. Okay. So I'm not following the same readings what I'm obtaining now. Okay. So you can see here the points. So randomly we have fixed some points. Okay. So it is ensured that the dial gauge is in 0 position. So 0.5 kg is added. So another 0.5 kg is added. So totally 1 kg is acting on a beam. Okay, we are not following these readings. Okay, this is for this video is for demonstration purpose. So third reading, one more 0.5 kg. Fourth, so totally 2 kg is acting on the beam. Fifth, now totally 2.5 kg is acting on the beam. This video is for demonstration purpose, okay? We are not following the readings. Unloading part now, okay? Unloading. Now for 2.2 kg, you write on the reading, the unloading part. From the bottom, you have to come, okay? Now another 0.5 kg is being removed. So another 0.5 kg is removed. So another 0.5 kg is removed. So now we move the dial gauge to the point 1 and weight anchor to the point 2. We are ensuring 0 position in the dial gauge. Point 5 kg is being added. So we are not following the dial gauge readings. This is for demonstration purpose. Now unloading. For every unloading, that is for every removal of 0.5 kg, reading is recorded written from the bot in the unloading column. Thank you. Thank you very much.